Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to have a very brief one. Okay, my task or our task here is to go through the solution of the assignment that was given in lesson 1 of elective maths, sequences and series. Okay, so as you can see on your screens, okay, this was the question. The question was in two parts. The first part, we were asked to express this recurring decimal as an infinite series. That's the first part. So after taking care of the first part, there is a second part. So hence, so meaning make use of the results in your first part. Find the sum of the geometric series, leaving your answer in a particular form. So the form P over Q, where Q is not equal to 0. So like I told you, anytime you read questions, make it a habit to underline salient parts. And now you are aware that hence is a very critical part of a question that must be underlined, because it means that your conclusion for that part of the question should take hence. Or, okay, in starting your presentation for the solution of this part of the question, you have to rely on your previous result, because it says hence. Anytime you see hence, then it means there is a previous result or there is a previous conclusion drawn. So if it was hence or otherwise, then it means, okay, you can use your previous results or use any other means possible to generate, okay, your geometric series, its sum in this form. But because it's hence is one way, one direction, use the previous results and conclude with hence as well. So as usual, you know, anytime a question is read, after reading your question and underlining the salient part, the first thing that you write is solution. So those of you who didn't write solution, okay, you realize that I wouldn't know, because some of you wrote, if you didn't write the question, then you presented your solution this way, I would even know that that is the solution. But where you wrote the question and you started from here, I don't know whether this is also part of the question or not. So if you write the question, then you have to, when you are through with the question and you are presenting your solution, you, okay, cannot avoid writing solution. In any case, whether you write the question or not, please, okay, after writing the question, don't forget to write your solution when you start presenting your solution. So the first thing that you write is your solution. After that, okay, you extract what you are given, okay, what you need, what you are asked to work on. So in this case, I've been given this recurring decimal 0.34, the whole of the 34 recurring. Okay, and I said, as you mature straight away from here, you can draw your conclusion. And as I walk you through here, because I've gone through your work, okay, I know the major concerns, so I'll address them. However, okay, after watching the video, definitely I will send the video to you. And if you have any outstanding concerns in our next meeting, you bring it up for discussion. So this, I can draw my conclusion here. If you don't draw your conclusion, it means when you are moving down, you have to come and write, okay, equal to. You don't write the 0.34 recurring again before you write. I'm talking about if you are not concluding, before you write the equal to. You avoid repetition, sort of. Okay, so in this case, I know I can draw my conclusion straight away. Okay, so in this case, I'm going to get 0.34 recurring with a dot on them. If you ignore the dots, okay, it's going to be critical. Okay, I mean, you will get the answer marked wrong, because 0.34 and 0.34 with a dot on top, okay, the meaning, okay, the two, they have different meaning. So in this case, I told you, and here, those of you who couldn't write this out, okay, it was infinite series form. Listen, I told you this was the advice. The first thing that you write, in fact, the first term I should say that you write will be your exact decimal there without the recurring on top. So that will be your first term. Your second term, so it will be plus. Your second term, this is all that you do. As you move on, okay, where you have your recurring digits, you replace them with what? With 0. So it means because I have two recurring digits, I'll write 0, then these two recurring digits, okay, I have to replace them by 0. Then I write the recurring digits again, which will be 3, 4. So because you have two recurring digits, after your decimal point, and the two recurring digits also come after the decimal point. So after your decimal point, these two recurring digits, you replace them with 0 before you write, okay, the digits again. So that is going to be the pattern. The first example that I gave you, because we had only one recurring what digit, Okay, we replaced that one by 0. So there was only 1 0 after the decimal point. But here we have two recurring digits. So each, okay, 2 zeros. So it means the next one, if I'm writing my next term, okay, the 2 zeros will be there. But now these two digits there will also be represented by two more, zeros. So I will get 4 zeros before I write the 3, 4 again. I guess my point is well made now. Those who couldn't get, okay, the pattern and the concept very well in the previous lesson. Then take note, if you end, okay, without bringing the ellipses, you are wrong. Because if you truncate it without the ellipses, then it means your recurring digit is no more recurring digits. Your recurring decimal, I should say, is no more recurring decimal. It's rather a terminating what? Decimal. So plus your ellipses there, plus the ellipses, okay, that will, okay, make sure that what you have here is equal to what is this. If the ellipses is not there, what you have here is not equal to, because you are going to get, okay, 0.34 recurring to be equal to, that's what you are writing. If you sum this with your calculator without the ellipses, you get 0.34. But 0.34 recurring obviously is not equal to this. So without the plus ellipses, please take note. Okay, it will be M0, okay, A0, because these two are not the same. So take note. So those of you did that, you saw M0, then marking becomes easy, A0. So this will be your first part. If you like, you can, okay, leave your answer in the fraction form rather than the decimal form. In that case, it will be 1 over, okay, 100 plus, okay, 1 over, I think, 10,000 over, so, sorry, 34 over, I should say, it will be 34 over 100, not 1. But 34 over 100, you can reduce it. So you don't leave it as 34 over 100. So you reduce the fraction to its, okay, common fraction form. So each of the corresponding fraction can be reduced. So you reduce, okay, or you do that as such. Otherwise, you can end with what? The decimal that you have here. So obviously, we can see that what we have here is an infinite series. And it will always be an infinite geometric series. So that's why, okay, we have this. So the first part of the question catered for. Now we are looking at the second part of the question. So you can start with hence or ignore the hence. Otherwise, in any case, if you start with hence, then you don't have to. It means you are drawing your conclusion for the second part straight away. But if you don't write hence and you write implication, use the implication sign. Please take note. Okay, you are supposed to draw your conclusion or bring hence, okay, at the final step here. So it will be hence, this is equal to this. But we are being smart because we know that we are supposed to conclude with hence. And again, okay, this reminds me, if you wrote this and you came to write implication here, you are wrong. That's the wrong use of implication. Before you can use implication, whatever you've written, whatever you extracted from the question, it should either be an inequality or an equation. And I'm repeating this because we have new students. I know that the old ones you have matured. You know when to use the implication sign and when to use the equal to. So because this is an expression, every step on the way, you have to use the equal to sign. If it was an equation inequality, that's where you can use the implication. Otherwise, you don't use the implication. So now, hence, 0.34 recurring. We know if I'm summing this, this will give me sum to infinity because I have an infinite number of terms that I am summing. Okay, and always this will be a GP, like I said. So sum to infinity of a GP will give us A over 1 minus R. So you can choose not to put this formula, okay, in the general sense, but use the particular values. But ideally, it is better. Put the formula and let the formula guide you if you are not matured. So this will be equal to sum to infinity. And you can see that as I come down, I write close to the margin. You should always leave room here for your rough work if need be. And especially so, now that we are dealing with constraint paper in elective maths, so that if your work doesn't go here, at least you have the liberty to rule a line and come and continue on the side. However, if you use this space, no matter how big this space is, you cannot continue there if you exhaust, okay, that page. So always move your work close towards the margin. Always move it to the side. So those of you fail to do so, you do that, you see that I will do this, then indicating that you should have pushed your work towards that side. And again, as you move from a step to another step, yes, a step to another step, don't leave any line unattended to. You don't leave any lines, please, especially those who, and I think those who joined, okay, the new student, they are doing that because the old ones, you know, these basic rules. So avoid leaving spaces between your steps. Okay, always every line must be used. You have to write something or in that line or on that line. So in this case, this is what we have. You put the formula. The formula requires that I will need my A and I will need my R. The A will be the first term of the series that we have here, which becomes the first term of the sequence. So A will be equal to 0.34. But I have in mind, per the nature of the question, and even again, I forgot. Okay, in every math question, whenever you are asked to leave your answer in a form, underline the form as well. So you should have underlined that one too after reading all the question. Okay, these two should have been underlined. So now what do we do? 0.34, you know I'm going to work with decimals. Oh, sorry, at fractions. So every decimal result that you get, take it to its corresponding fraction. So that's the more reason why I wrote equal to. Somebody can write but take note, if you come and write but here, okay, assuming you wrote but, okay, I mean on this line without writing the equal to, A is equal to whatever, then R is equal to what you have there. You cannot come and write equal to again. Once but, okay, comes, you write this, whatever you have here, okay, interfered, remember. So it means if you are moving on to the next, you have to write this side again before, okay, you can write the equal to. Take note of that. So those of you who did that, remember, I'll write M0, A0, something as interfered. So if you write A, but A is equal to, then you don't write anything here, you write equal to, I will assume it is the A that is equal to this. Because anytime we are talking about equal to, you go to the above, okay, the step above and see what is there that you decided not to write because something must be here. Okay, you can see that here, I wrote equal to here. I didn't write this because if I go above, what I have here is what must be equal to this, which carries the meaning that I want to put across. So take note of these basic things that will, if you don't take care, will deny you of vital maths. Okay, then, and R is equal to, you know, your second term over the first term. So that will give us this. But your calculator will give you your result in decimal. If it gives you your result in decimal, change it to a corresponding fraction because you know that you want to work with fractions. If you want to work with decimal and later change your decimal result to fraction, then you end here. The A will be 0.34, and this one too, you leave it in a decimal form. Don't mix the two. Don't substitute decimal and fraction at the same time. If you are working with decimal, substitute decimals throughout. If you are working with fraction, substitute fractions throughout. So in this case, I get a corresponding fraction of this, then I just come and substitute A, which is this value, over 1 minus this. And please, if you write this, and I told you in the previous lesson, if you write 17 over 50, then you come and write divided by 1 minus 1 over maybe 100, or you use the decimal. Please take note, these two, this and this, are not the same. This one means it is only this one that is being divided by 1. Okay, if you want to maintain the meaning, then you have to put it in brackets. So I said, first of all, do direct substitution. So the direct substitution will be here. This is the direct substitution. So A, 1 minus R. Before you can change this bar to the symbol, make sure the numerator is a single fraction, which is, and the denominator, your next step, you take this one, okay, as a single fraction, meaning you do 1 minus 1 over, which will give you 99 over 100. So in that case, I have only a term before and after the division symbol. Therefore, brackets will not be necessary. But if you have a term, more than a term, either before or after, and you change this bar to the symbol, you have to put, okay, the one with more than a term in bracket to maintain the meaning. Otherwise, you are doomed. So it will be, if you ignore the brackets, okay, so if you ignore the brackets, okay, here, you get M0, A0, take note. So at this point, you are in a comfortable lead. It will just become, so change this one to multiplication and invert, okay, and okay, reduce. Just feed this with your calculator. Your calculator will give you the reduced version. Don't just go and cancel. It's JHS that because you don't use calculators, okay, you will be canceling, showing your cancellation, so you get your simplified result. But here, calculator can give you the result straight away. So don't stress yourself. Use your calculator. And remember, okay, this hence is here. So indirectly, you've drawn your conclusion. You cannot come and write therefore. Take note. Your conclusion should take hence. So if you didn't write the hence, then you are now coming to write hence, whatever you were asked to, okay, which is this, is equal to this, but you cannot end here. Remember, I told you, the form contains, okay, or no. So though you were asked to leave it as a fraction, okay, the fraction contains letters. So you compare and attach the values of the letters. And please, you cannot write hence P is equal to 34 and Q. You were not asked to find the values of P and Q. So you cannot conclude with it. This is just an attachment to your value that you have here for you to get the format. So those of you who ended here without this, it will be A0. Those of you who concluded with therefore or hence P is equal to 34 and Q, you get A0, wrong conclusion. Because we are not, that's as I said, you are not asked to find. If the question asks you to find, express it in this form, and hence find the value of P and Q, then you draw your conclusion with the P and Q values. So anytime you are concluding, let the nature of the question guide you to conclude. So here the question asks us to write this as an infinite series. So after getting the infinite series, it was this that I was asked to write as I conclude with this. The second part of the question, I was asked to find the geometric sum in this form. So it will be, if you conclude with sum to infinity, that's okay, therefore sum to infinity. Otherwise, it should be this. This, in terms of its fraction, that it is this one that you were asked to write it in terms of its fraction, which should be this. Okay, and you attach this. I guess my point is well made, and all major concerns underline, taken care of. So if you have any other issues, like I said, okay, please, okay, if there is any comment that I passed that you couldn't relate, okay, make sure you note it down. After watching the video and it's still not addressed, okay, please, in our next lesson, like I said, bring it up for the discussion, because I will always give you that opportunity before we move on to, okay, the next concept that you need to know. So at this point, thank you very much. Okay, have a wonderful day, and God bless us all.